Today we are going to make a start on our electrics, but we are only going to be doing the ones up above because we want to have all our cables in situ before we do all the insulation and like the cladding and stuff on the roof. And we just want to say, the cable that we picked for our build might not necessarily be the one that's correct for your build.
That's right, but we are going to explain how we selected it, so hopefully it'll be useful. We've included the tools that we've used and the people that we've used to ratify it as well. So yeah, that's what we're doing today. Hope you enjoy. Okay, so the world of 12-volt electrics is completely new to us. So we've done a lot of research on getting the cable diameters and everything right. But there's 4 ways really that you could figure this out yourself. So the first way is to pay someone else to do it. So there's a couple of people around that can help spec your system, build wiring diagrams for you and this, that and the other. The second way is to do that and then have someone else install it all for you as well, which is not out of the question, but the cost would mount up. The third way is that you can do it yourself, and that's what we've sort of done. And the fourth way is actually what we've done, and we've done it ourselves in that we've sized everything and then we've checked it with Chris from BSPK Solar. So the key thing is that we wanted to make sure that we didn't use loads of different cable sizes. What we've decided to do is to go for the upper range that will work for most of our current loads, and then use thicker cable for the oddities really. So the basic thing that you have to do is work out, first of all, what amperage your things are drawing. So there's a couple of ways to do that. The easiest way, if the manufacturer supplies it to you in the instructions and tells you what amps it's drawing, what cable to use and what fuse to use, you can go ahead and use that. That's fantastic. It will probably list in there cable lengths and all of that, so fine, check that first, check the instructions, see what it says. If you don't have that in the instructions, it will state the watts, the voltage or the amperage in there, and you can work out the amperage by taking the number of watts and dividing it by the voltage that your system is running. So for example's sake, our lights that we've got going up here, we've got 8 of them. They each draw 3 watts, so 3 times 8 is 24 watts. If you divide that by 12 volts, because we're running a 12-volt system, you end up with 2 amps. So we would then know that we would need a cable capable of carrying 2 amps. The next thing that you need to consider is the length of your cable run.
The reason for this is the cable's main job is to transfer current with the least amount of resistance from your battery to the appliances that you're powering. So every cable has a certain level of resistance, as do the loads or devices that you will have in your circuit. And you must account for this in your run. If your cable is too small a gauge, it will heat up, potentially causing a fire, and in the extreme, or at the very least cause your appliances to be overworked or not run correctly. For example, you could have dimly lit lights at the end of your run or even your entire run, motors on your fridges working too hard. Hopefully this can be easily combated by calculating your correct cable diameter, accounting for voltage drop.
So you need to take into account the full journey of the cable. So the electricity path for your positive, all the way coming back through your negative to wherever you're terminating that to. The easiest way that we found to do that is to use an online calculator. So let's take that example of the 2 amps that we have in our seeding. We have overestimated that our cable run will be 6 meters for that. So we can put it in the calculator that I'm just going to flash up on screen now, and that will tell us that we can use 21 amp cable, so 1.5 millimeter cable, or 16 AWG cable if you're on American wire gauge, and that's what we're going to use. And we're going to use that in our build for the grand majority of things, because we've run it through the calculator and we know that for most things, not all, but we'll cover those as we're going through them, the 1.5mm cable will work. In summary, what we did, we worked out the amperage of the loads that we're using in the ceiling. Remember, we're just doing the ceiling stuff today. Did that first. Then we worked out what the cable run's going to be. We ran it through the calculator, and that gave us the cable diameter that we're going to need to use. And we'll leave the links down below for the cable calculator, and we also found a calculator to calculate your amps as well. But like I said, that is a simple equation really. It's your watts divided by the voltage that you're using gives you the amperage.
The final thing that I decided to do was to add all of my components, loads, whatever you want to call them, into a spreadsheet, and then where I needed to add the watts, how many are on the run, total watts, the current, which in my system is 12 volts, and then that allowed me to calculate the amps. And then from that I worked out the cable run and then popped it in the calculator to tell me what the cable should be. So I've got this as a reference point now. I can also calculate the fuse, so now I know how many amps there is on this. I can use a simple formula of multiplying that by 1.5 and then choosing the next highest available fuse, whilst taking into account that that is suitable for the wire that I've chosen. Likewise, you could also look at the instructions, and that might tell you what size fuse to use, and then you can work yourself backwards then.
This is where the solar cables come through inside this conduit into the roof, and then we've got it going through here and out here, and then this is going to come down into the wall here, which would be the bathroom wall. We decided to go for the 6AWG cable, which is the standard cable that most people use for solar. We have already installed the electrics for our reversing camera and also our backlights.
Okay, we bought this cable feeder thingy. Yeah!
How much?
Should be enough. Basically, what this is a twin core cable for our lights. So I'll include the wiring diagram from a thing I found online, but basically we want the ability to switch the lights on at the door and switch them off at the bedroom. So what we're running here is the 2-core cable that will run to each of the lights up on the ceiling, and we're going to do that now and just tape it up so we know that we've got enough cable. And then what we'll need to run when we do the bottom set of cables is a tri-core, triple core wire all the way along here to the same switch, and then it basically links the two switches together to allow us to switch it on here, switch it off there, and vice versa. So we're going to do that for this set of cables. So the cable that we've got here will run to our rocker switch down in the corner. It runs up through this pillar. We're going to run it for our lights along here, up to the end of the living area, across and back in one continuous loop, and we're going to pull like loops down because that's what we'll cut and attach to our LED lights, which we'll show you in a future video hopefully when we do the ceilings.
So that's that run. We run it very loosely, so we've got enough spare cable. We'll actually take that down now because we're going to insulate, well, we're going to vapor barrier over this. I'm just going to coil it up and put it over there. And we've got we've used some of the labels that come with the label gun to label the lights that go in, and they're just stupendously massive, but it is what came with it. So we're just labeling up this cable as we go so we don't forget what they are. But again, this one runs up here and out of grommet and does come up here. Not ideal, but we will be covering all that over with the cupboard. Oh, it's scorching. The girls have just gone inside to cool down a bit. I'm going to go have a drink, but before I do, let me show you so for the wiring for the maxxair, I have used these heat shrink connectors. I twisted it up first, nice and tight, and then pop these on, and they're solid now. So I'm just going to run this cable to the back, because it's going to come all the way along here, along with some other upper lights for our cabinets. So we're going to have some mood lighting in under the cabinets. We're going to run the cable for that now also. For our wired smoke alarm,
and all of that's just going to come along here and then come down in our wall in some conduit down this side. So running along either side of the vehicle, you've got various factory wiring. Because I'm running so fewer cables up here, like, you know, I'm running this one for the maxxair, gonna run one for under counter lighting over this side, gonna run one for a fan over this side as well, which will be useful on days like today, and a couple of other bits. It makes sense to just run it along with that factory wiring, and then what I'm gonna make sure I do is just zip tie this together in under there, just as it is with the factory wiring, to make sure it doesn't chafe. There's a channel there for it to use it, so I thought I may as well use it. On the other side, when we get to it, I'm going to do it slightly differently because the cables we're running over there are much fatter.
So we've run the cable for the maxxair and for all of the living lights. We're just packed up for today because it's too hot, so we're just going to go through each side of the bus with you to see what we've installed and show you why and what we've put up there, and how we're going to keep it safe. That was our best intention, but unfortunately, you know, I have to work in the week, and Kelly and Lily are also very busy in the week, and it was really hot in the week, so it's too hot. So it's Saturday, and we're going to run some more cable now, hopefully get this finished today. We're going to start off with the passenger side. We've got cable to run for our LED mood lighting, for our fan, for the special lights that's going in Lily's room. What's wrong now? I love you too, Bobbit. And that's what we're doing today.
We've decided that we are having cabinets along here and along here, but we want the underneath lighting on there, don't we? Yeah. That's doable. So we are thinking we'll probably have around 2 meters each side, and each meter takes about 5 watts.
So what is 4 times 5?
20.
20 watts. And if you divide that by 12 volts, that's roughly 1.6 amps. So again, we run it through the calculator and we know what cable for our run we need to use. So we're going to run that now.
Going now.
Lily's making her own labels and printing our labels.
I'm
to these
writing green.
Nice. Just having a little mid cable run, excited moment, and we think good idea, but we're just going to go and get some of our stuff to see if it will work. Basically, when we're running our cable, this is going to be in conduit, come down through an end wall here. Now Lily's bed, we think, is going to be here, come out to 60, 70, all the way along, leaving a cupboard underneath. And what we think we can do with that top portion of the cupboard is maybe utilise that for an indoor fuse box, because we were going to put it in the garage. But I've bought 2 fuse boxes. I'm thinking we'll put one in here that we can run all of our stuff down into, and then just have a, you know, our big cable coming up and powering it. And then in here as well, we think we can have our control panel for our servo, things like our diesel heater, level gauges, all of that stuff. But I'm just going to go and grab that stuff to see if it will fit in our makeshift cupboard, which is also genius.
All the best jobs. I get to be a cupboard and hold the fuse box in there.
Yes, but it's a very attractive cupboard. I think you'll agree. So what we're thinking here, the cupboard will be about this wide. We found a box, so it's about 25 centimetres wide, and it was going to come from here underneath Lily's bed all the way to the floor. But we're thinking in this cupboard we can actually have our internal fuse box and run our cables down into here, along with a bunch of other switches and things like that that we know that we want access to inside the living space. And then for stuff that we don't need access to regularly, we can run that to a separate fuse box down in the garage.
Little helper.
So that's our idea, that's what we're going to do. So we'll save a lot of cable runs up here and save having to traverse the bus as well. Some of it we do need to work over to the other side, which we're going to do next. But yeah, we'll be able to access our fuses from the living area, which we weren't going to do this. So we're pretty pleased we thought of this as we're going through and not in the middle or at the end of our build.
Yeah, we think it will make things easier.
We think so. Over here, this is, like as we mentioned, in our fuse box now, we have run stuff in various gauges of cable down, and we're going to put this in conduit next. We've got a couple of bits that won't come down from above, they're going to come up from underneath, from behind the bed. But we have got that already taped up around here. So for example, the bedroom lights, the bathroom light here. We're going to actually run for the IMAS a cable up, over and around that will come around. So as we mentioned, these labels that came with the gun are all on here now. We've put them on both ends where appropriate, so we know what links from one to the other. And then when we wire these up, I will use some heat shrink instead on these, because the printer is really smart and printed heat shrink, so we know what goes where. But we've run all of that stuff now. Conduit next, and then we need to figure out down this side over here basically how we're going to run our 230 volt along there, because we want a run of that for a socket and a 3mm cable for our USB sockets that we're going to run down that side too. So I think I'm going to run that just like the other stuff, up high and then back down, just so the cables are out of the way really. We could have run them in the wall. It would have required drilling out of the upright supports, which we weren't really keen on doing, but you know, that's an option that we could have used. But we've decided for this, you know, in hindsight, maybe that would have been easier. But as you know, when you're going through the build, sometimes hindsight's a wonderful thing.
What's occurring, mate?
Just taping these wires up, and we've zip tied them all the way along now so they won't chafe or rub. Really?
Daddy's go.
We'll just do one more calculation, just to show the calculator works. So this stuff is heavier gauge 3mm cable. I'm using this for USB sockets in the living area. So the plan is we're going to at least have one down by where the passenger seats are. But I wanted to be able to run two if I wanted to. Daisy chain off one another. Like I was trying to put one here where the sofa is, and one at the other end. I'm going to use the calculator. I'll just flash it up on screen. So we can see here that I can adjust the voltage drop. So I'm going to go for 3%, which is acceptable for 12 volt loads. And I'm going to put in there enough for two of these. So the USBs that I'm looking at are 2.1 amps each maximum. So that's 4.2. I'm going to press calculate, and then that will give me, it says 2.5mm 17 amp cable. I'm going to step that up again to the 3mm that I've got, which is good for up to 33 amps. Knowing that whatever I put through that, then it will all be fine and dandy. And likewise in the future, if I switch those out for any other upgraded USB chargers or anything like that, I know that I won't need to run a heavier gauge cable because it's already there. Last couple of bits to do, so I'm going to run one final cable along here for our 230 volt. I'll just go and grab that cable and show you. This here is a 50m drum of 2.5mm 230 volt cable. So this stuff is blue because it's Arctic cable, which means basically it's flexible. So instead of like your household 3-core that is a solid core wire, this has multi-strand inside, and also the sheath is very thick and is designed to work in extreme temperatures, you know, be that hot or cold, and still be able to work and not break on the inside or perish. So this stuff is not very dear to buy actually, especially if you buy it, you know, in 50-meter lengths or, you know, whatever they kind of come in, and is readily available. This is what we're going to use for our 230 volt, which we will cover in a future video, but for this one I am just going to run a length of it down to where we need to have a socket at the front, and then you'll be seeing a bit more of this in a future video. We're not going to have tons of sockets in here because we're going to try and actually use 12 volt for almost everything, but naturally we wanted the ability to be able to use higher power things through our inverter should we need to. Yeah, and we'll cover, if you like, in another video of how we've chosen and spec'd our system. Let us know if you'd like to see that, because we're not sure, you know, we know why we've chosen it, but we don't know if it'll be of interest to you all. So let us know down below in the comments. So yeah, I'm gonna run this now along, and then we'll zip tie the rest of this stuff up so it's all nice and tidy. Conduit I've got here, you can see that this will run down. So imagine this is our end finishing wall here. It's gonna run down our wall here into the cabinet where the fuse box will go. On the other side, it'll be the same story. I just want to look up, so I'm gonna go and do some research tonight before I actually finish this 230 volt and run it in the same path as my DC, because I'm not sure if that will cause me an issue or not. So I'm gonna go check that. Any Sparkies out there, do give me a shout. So we are gonna give electrician a ring as well, and see what they say about it, and they'll be coming and checking all of this stuff as well before we commission it. The 12 volt stuff, like I said, Chris at BSPK Solar has been good as gold.
The majority of our up-high cables are now in, so we're super pleased, although we do need to think about our speaker cables. We will include all the links below for all the where we got the cables and the tools we used.
And you know, anything that we've mentioned in here around cable sizing, we've shown you how we made those decisions for the cable sizing, but it's likely that that won't suit your build. If so basically do your own calculations. Hope you found it interesting today. We've really enjoyed running all this. Feels like a good step forwards. Leave us a comment and like, and we hope to see you in next week's video.
1, 2, 3.
Bye!
Oh, that was good. No. Remember those things you used to get when you were a kid? You don't need to buy one of them, just get some conduit.